Okay, in this presentation, what I'm going to do is look at clustering analysis of the iris dataset, but I'm also going to do some data cleaning because probably each machine learning a machine learning task would have a fair amount of data cleaning involved in it. Okay, so I'm not going to do a lot, but essentially I'm just going to do some column operations actually, just to sort of, you know, earn our right to do the very simple analysis that is clustering analysis. Okay, so from essentially we import all our main packages like pandas as PD, numpy as NP. I'm not sure if I'm using that actually, but I'm definitely using pandas. From Scikit-Learn, we're going to import cluster. Okay, now I'm going to import a special version of the iris dataset. Basically, I've amended it just to make it a little bit dirty. Okay, so it's iris-skl. Okay, so you can read the address there. Just to remark, it's a raw URL, and if you just click on raw, when you're looking at CSV files on GitHub, it gives you the raw version where there's no formatting, and you're able to import them very easily. Okay, so I'm going to import that as iris. So iris equals PD, which is pandas, dot read underscore CSV, and just put in the URL. Okay, it's a lovely little way of getting data sets in and out of Azure notebooks. Okay, so let's just see, did that work? Let's run a few of those. There we go. Yeah, there we have it there. Now, I didn't do anything extraordinary. Essentially, I just changed the names of the variables such that they have white space in between the two of them. I don't even think that's actually a major matter. I just want to get rid of it. That's all. Okay, so you can shorten it or replace the names, but in this case, just what I'll just sort of do, just sort of, it's my peculiar fondness for doing this right now is just to get rid of that white space. Okay, and just actually look at column operations as well. Okay, so the column names, so just actually print them out to list. There we have them as a list. So we seem to have 5 columns. Okay, now species is the label actually, but you just have to learn about that by learning about your data. Just actually this business of to list is actually just a sort of, this is what happens if you just print out the columns. It just gives you something like that. But to list is a nice neat output. Okay, so I just like to list better. Okay. Now, what I'm going to do here is iris.columns.string.starts with is that we could just actually use this as a sort of like a list of string items and just sort of see what starts with things like sep. So here I'm able to pick out all of the column names that begin with sep. Okay. For example, you could do it with petal as well. Let's just change that. There you go. Now, the reason is actually because, I mean, there's only 5 columns in this particular data set, this data frame. But I've seen other data frames where, like, and it's nothing extraordinary, where there'd be like something like 200. Okay, and you can't have to process them all. You won't be able to just read them out. You need to just process them a bit better. And also what happens is you just need a sort of knowledge about what your data set is about, like sort of like in this case sepal length and petal length. I mean, it's pretty clear if you have an interest in botany what those mean, but other things like you might get you might need a data dictionary. Okay, so you just need to know what's in there and so on, and just check what should be in there isn't there. Okay, so string dot starts with pet. Okay, there's also ends with. So with as a DTH is with. Okay, see, does that to list thing works? Do I need to put brackets in there? I do. There we go. Okay. Now this is important actually. This is the big step I'm going to take. And it's nothing really major really. It's essentially essentially all I'm going to do is just get rid of the white space. Okay, it's just my sort of token bit of data cleaning here. So essentially, the white space is here. It's just in those quotes, just a white a space, and then here, just two quotes right beside each other, which is no white space. Okay, there we go. So what happens now is that the white space has been got rid of, essentially. Okay. So, okay, let's look at, so the iris, actually, just check what happens now. Sorry, I just overshot myself a bit, or went a bit too fast there. Let's just go iris.head and see what that does for us. You see that didn't work all completely. So we have to update it. Now, okay. Essentially, just what I did there is just renamed, just replaced the old names with the new names, essentially with the text amended. Just actually, this is just a sort of peculiarity that I wanted to do this for this particular video. But so I just to sort of demonstrate, because these column operations tools are very handy. So there's the head of iris. Okay. So we have 4 numeric variables and 1 categorical variable. So the categorical variable is going to be the label for each of our categories. And the 4 numeric variables are the predictor variables. Okay. So iris species.head. Okay, so I mean, it just gives you a count of the essentially, just actually you can list them out there, but essentially there's Setosa, versicolor, and virginica. Okay, so what I want actually is to find out how many of them are of each in each category. Okay, because like they're in order here, so that doesn't really tell us a whole lot. It just tells us the first 5 is Setosa, but it doesn't tell us about what the rest are. Okay, so I pick out the iris column, the species column. Okay, and I'm going to do a grouping operation. Okay, by species. Okay, and just sort of count out how many is in each category, essentially. Okay, so count out how many is in each grouping. Okay. So that sort of creates a grouping structure, and this simply just counts out how many is in each category. Okay, so there's 50 Setosa, 50 versicolor, and 50 virginicas. So that's how you essentially just get for your observed data, your raw data, just actually sort of count out how many is in each category. Okay. So I sort of can skip that bit now because essentially that's sort of just to, where am I gone? That's sort of just to yeah, I don't really need to do that. Now it's just really just sort of double checking that my name changed work. So it's essentially I can sort of skip past that. Now, just actually as a remark, you can rename columns. This is just a sort of format there to format to get rid or to just update names. It's sort of data dictionary approach. Okay, so data frame equals data frame dot rename, columns equals just a sort of a list of the updated names and correspondence, the old name and the new name. Okay, so I mean the string replace approach is just happens to be very useful in this particular instance, but it might not be useful in all approaches. So you can actually just spell out, if you want to change the name. This is like for some particular reason. There's no sort of heuristic. He just needs one new name to another new name that just you can just actually just rename them like that. Okay, so yeah, I sort of went past a few of those. So I'm gonna skip down a bit and I get down to my video or my clustering. Okay. So we're just going to pick out the columns that we are working with. Okay. So I am going to look at those are rows there. So essentially, sorry, actually, what I want to do there is that's just a sort of a row operation. But I just want to sort of pick out that we need our four. These are our four numeric variables, and we're going to need to separate them out so that we can create our training data set. Okay, so I'm going to use integer location in this case. Okay, so just actually this is a handy thing to learn about iloc. Okay, and so essentially, as well as starts with and ends with, this iloc for columns. Okay, so iloc is integer location. Okay, and that's all rows. Okay, and the first column. Okay, which is sepal width. Okay, now head 5 is just actually just to sort of not to be that, so it doesn't take up the whole page. So I just amended that just to make it sort of have everything fit on the page. Okay, so I want the first 4 columns. Okay, so it's actually 0 to 3 are the actual indices, but if I type in :4, that will give me the first 4 columns. Okay, so that's what I want. Perfect. And again, that's the head. That's just the first 5 cases, but I mean, I can just disregard that. Essentially, I've got the right columns picked out, which is great, and I'm going to set them up as my features, as my training data set. Okay, there we go. Perfect. Now I have my training data set up, and my features set up, and now also I can actually just pick out the target as Setosa, as species. Okay, so the target is just for later on. Okay, alternative approach. I'm going to leave the alternative approach. I'm going to get on to the k-means clustering now, actually. Okay, so what did I do here, actually? Pandas series. Just actually sort of remark it's a series, actually. Okay. The reason is because I think you need to sort of just it helps actually just use work with a series. Okay, because you can actually separate out a column and it will be have the sort of be structured as a data frame. Okay, so anyway, there's my k-means analysis. Cluster dot k-means, capital K, capital M. Number of clusters equals k. So in this case, I'm going for 3 clusters. Okay, and there we go. We've fitted our model. Okay, with the iris features. Great. Okay. Now I could put in a few of those other iterations, but those other arguments, but I'll just leave it to the bare basics there. Now put in our labels and our centroids. Okay, so let's print out the labels. Now the labels are the groupings that essentially 0, 1, 2. These are the groupings that have been assigned based on to each of the instances in the data set, based on the features. Okay, so essentially what we have here is the predicted values of the predicted categories based on the features. Okay, so that's grand. Okay, but what we want to do actually is see how we got on. So essentially what I'm going to do here is do a quick cross tabulation of the targets, which is essentially the species category, versus labels, which is the predicted category. Okay, and for the most part, things seem to go quite well. Now, the only thing I just don't like about that cross tabulation is that it is a little bit, essentially what you would do is that it should, the true cases should be aligned along the diagonal. Okay, so what I'm going to do here is just see, can I rearrange the cross tabulation? Yes, I can. Okay, essentially just reorder the column titles. Okay, and re-index it. Okay, such that the main cases, the true cases, are along the diagonal. just a sort of aesthetic point. So essentially, what that means is Setosa should match up with predicted category 1, and seemingly does. That's a pretty good match. Versicolor should match up with predicted category 2. Again, pretty good. Virginica is a bit hit and miss, but altogether pretty useful outcome. Anyway, we'll leave it there.